This is a supplement to lesson 3.2, measures of spread, and it covers Chebyshev's inequality. Okay, things that we know about Chebyshev's inequality. First of all, it's going to hold for any data set. So in order to use the empirical rule back here, we have to know that there's that bell shape to the histogram. Okay, so what you're looking for to be able to use the empirical rule is, does your histogram suggest this shape right here where your mode or your mean is right here in the middle, and then the data kind of tapers off to each side. Now, as far as Chebyshev is concerned, that doesn't have to hold true. Now, you can use it on bell-shaped information, but it's not as accurate as the empirical rule is, and so it's not really a good idea to do that. But if we have any old set of data and we're not sure if it's bell-shaped or not, we can use Chebyshev and we can get a good idea of how much of the data falls within 2 or 3 standard deviations. Now, they give you this formula right here, 1 minus 1 over k squared. And k stands for the number of standard deviations away from the mean that we're looking at. With the empirical rule, we looked at 1 standard deviation, 2 standard deviations, and 3 standard deviations away. So we would have, according to the empirical rule, the mean would be right here in the middle. And if we move 1 standard deviation to the right and 1 standard deviation to the left, we can be pretty sure that 68% of the data is going to fall inside this area right here. And if we move another standard deviation to the left and to the right, we can be pretty sure that 95% of the data is going to fall within this area right here, this whole thing. And then if we go another standard deviation out to the right and to the left, we can be pretty sure that 99.7% of the data is going to fall within this whole area right here. So these 3 standard deviations cover pretty much the whole curve. We do have a little bit of room out here for some outliers, but for the most part, we're sure that almost 100% of the data is going to be 3 standard deviations or less away from the mean, either to the right or to the left. Okay, now with Chebyshev, we can't do this with 1 standard deviation, because if we use the rule for 1 standard deviation, then the formula is going to be 1 minus 1 over 1 squared. Okay, well, that's going to give me 1 minus 1 over 1, which is going to give me 0. Okay, the problem with this is if I want to turn that into a percent, and I would be multiplying that by 100%, I'm just going to get 0%. So that really doesn't tell me a whole lot, and we can tell back here by the empirical rule, you know, there's going to be something in there within 1 standard deviation of the data. There's got to be something in there. It doesn't necessarily have to be 68%, but there's got to be something in there. So we can't use it for 1, but if we're 2 standard deviations out, so that means your data may be, you know, shaped like this right here, so that your mean is not included here at the highest point of your data set. It's probably going to be back here somewhere. Okay, and if we move 1 standard deviation to the left and 1 standard deviation to the right, there's not a whole lot we can say about this, which we just showed up here by getting the 0%. But if we move 2 standard deviations away, okay, now let's use the formula when k is equal to 2. We have 1 minus 1 over 2 squared. That's going to be 1 minus 1 over 4, and then that's going to give me 3/4. And if I take 3/4 and convert it to its decimal, it's going to be 0.75. And then we take 75 and we turn it into its percent by multiplying by 100%. That's going to give me 75%, which is right here. 3/4 or 75% of the data is going to fall within 2 standard deviations. So in our picture, that means between here and here, we can be relatively certain that 75% of the data is going to fall inside those 2 deviations there. All right, so if we want to do 3 standard deviations, let's go back and use the formula again. This will be 1 minus 1 over 3 squared, because remember K stands for the number of standard deviations. This is going to give me 1 minus 1 over 9, which is 8 over 9. And if I convert this to its decimal form, it's going to give me 0.88888, and so on, which we could round to 0.89. And then when I turn that into its percent, I'm going to multiply 0.89 times 100%, and that's going to give me 89%, which is right here. And that means if we move a 3rd standard deviation to the left and a 3rd one to the right, we can be pretty certain that this is going to be about 89% of the data, and that's going to be from here all the way over to here. Okay, so when you have the percentages given to you, or when you have K given to you, it's probably going to be 2 or it's going to be 3. We don't usually go 4 standard deviations away from the mean. That usually includes the outliers. And there's not always data out there either. Sometimes 100% of the data is included within 3 standard deviations. All right, so if you're working ALEKS or you're doing a homework problem and it asks you what to do when K is equal to 2, there's no point in using the formula because we already know what the percentage is going to be from using the formula when K is equal to 2. Likewise, when they give you a problem and ask you what happens when K is equal to 3, I mean, you can use the formula, but there's no point for it because they've already told us what the percentage is going to end up being when K is equal to 3. Okay, so let's look at a couple of problems and see how this is going to work out. Okay, here's the first one. What's the temperature? The temperature in a certain location was recorded each day for 2 months. The mean temperature was 62.4 degrees Fahrenheit with a standard deviation of 3.1 degrees Fahrenheit. What can you determine about these data by using Chebyshev's inequality with K equal to 2? Okay, so from the previous slide, we already know that K equals 2 means we're talking about 75% of the data, and that's going to have to be within 2 standard deviations. All right, let's take a look at our picture. And I'm just going to draw the bell-shaped curve. It won't necessarily be a bell-shaped curve. That's the data, but I'm just going to draw it in here. The mean always goes right down here, down the center of the graph, okay? All right, we got 62.4 degrees here. All right. Let's not do that. Okay, so 1 standard deviation, we know would be including the interval 62.4 minus 3.1. This is when we went to the left, 1 standard deviation. And then 62.4 plus 3.1, and this is when we went to the right, 1 standard deviation away from the mean. Okay, so that's going to give me, let's see, give me a calculator. All right, 62.4 plus 3.1, that's 65.5. That's this one right here. And then 62.4 minus 3.1, that's going to give me 59.3. And so over here on my picture, 1 standard deviation to the right, this is going to be 59.3. And I'm writing these vertically because I'm not going to be able to fit them all in there. And then, whoops, I just did that wrong too. Let's erase that. All right, let's try that again. To the right, we had 65.5, so 65.5. And then one standard deviation over here to the left is 59.3. Now remember, we can't say anything about the percent of data in here because when we put 1 into our formula, we ended up getting 0%. So that's not going to help me at all. But it will help me get to my second standard deviation, which is what they're asking me for right here. All right, so my second standard deviation is going to take 62.4, and we're going to subtract 3.1 to get to one standard deviation, and then we're going to subtract 3.1 again to get to that second standard deviation. So see, I'm really subtracting 6.2. And that's going to give me 56.2. And then when I go the other direction, so I'm going to move to the right 2 standard deviations. That means we're going to take our mean, 62.4. We're going to add 3.1. Then we're going to add 3.1 again. So that's 1 standard deviation, 2 standard deviations. And that gives me 68.6. So on my picture over here, my second standard deviation to the right is 68.6, and my second standard deviation to the left is 56.2. All right, now let's answer our question. What can we determine about the data? We can determine that about 75% of the data falls between 56.2 degrees Fahrenheit and 68.6 degrees Fahrenheit. And that's all there is to it. Okay, let's look at this other example dealing with Chebyshev. This is all about the price of electricity. The Energy Information Administration records the price of electricity in the United States each month. In July 2013, the average price of electricity was 11.92 cents per kilowatt hour. Suppose that the standard deviation is 2.1 cents per kilowatt hour. What can you determine about these data by using Chebyshev's inequality with k equal to 3? Okay, let's remember what k equals 3 means. It means we're 3 standard deviations away from the mean. And we can use the formula, right? We would do 1 minus 1 over 3 squared, but we've already done that. We did that back here. And we found out that 1 minus 1 over 3 squared gave me 89%. So we know that we're looking for roughly 89% of the data. Okay, let's see if we can figure out what the endpoints are on that 89%. We'll draw our picture. We're going to put the mean right here in the middle, which is 11.92. And we're going to move to the right 3 standard deviations. That's going to be this point right here. And we're going to move to the left 3 standard deviations, which is going to be this point right here. And then we'll be pretty certain that the distance from here to here would contain 89% of my data. All right, let's figure out what these numbers are. All right, 3 standard deviations to the left. That's going to be 11.92. minus 2.1, there's my first standard deviation, minus another 2.1, there's my second standard deviation, minus another 2.1, that's my third standard deviation. So we're actually subtracting 6.3. And that's going to give me 5.62. All right, so what that tells me is this number right here is 5.62. Now let's get this one over here on the right. 3 standard deviations to the right. This is going to be 11.92 plus 2.1, that's 1 standard deviation to the right, plus 2.1 again, that's 2 standard deviations to the right, plus 2.1 again, that's 3 standard deviations to the right. So we're actually adding 6.3. And that's going to give me 18.22. And what that tells me is that this number right here is 18.22. All right, let's answer our question. What can we determine? We can determine that about 89% of the data will fall between 5.62 and 18.22 cents per kilowatt hour. Okay, I hope that helps y'all a little bit with Chebyshev.